Let's learn about the types of networks. Here are three main types of networks, namely Local Area Network, also known as LAN, Metropolitan Area Network, also known as MAN, and Wide Area Network, also known as WAN. A local area network, or LAN, is a network that connects devices within the same building and are usually private networks. For example, a home Wi-Fi or an office enterprise network can be a LAN network. A metropolitan area network, or MAN, is also called a campus area network, or CAN. It is a network of networks, is limited to a campus, and can be extended to an entire town or city. For example, a company's branch offices across a city are connected to the company's central server located at a data center at the company's main office. These networks are created to keep the systems of the organization safe while company information is accessed and exchanged among each other from the organization's data center. Another example can be a university network. The last category is a wide area network, or WAN. This is a network of computers and spreads beyond the boundaries of a building, city, or even a country. A classic example is the Internet or World Wide Web. It is the worldwide research and defense network that shares information across the globe or even with space stations away from the Earth while keeping the information secured from people who are neither a part of the network nor authorized to access the network resources. Let's learn about the types of networks. There are four common types of computer networks. In this video, we will describe them in order of their size, from smallest to largest, namely Personal Area Network, also known as PAN, Local Area Network, also known as LAN, Metropolitan Area Network, also known as MAN, and Wide Area Network, also known as WAN. PAN, or Personal Area Network, is a very small network. Bluetooth connections are an example of a PAN. It connects personal devices to each other, like computers and printers, laptops and phones, even headphones. A PAN is much smaller than the next network type, the LAN. Bluetooth is a technology of a PAN, but it could also be wired by USB or FireWire and wireless ultra-wideband, or IRDA. Local Area Network, or LAN, is the most common. It connects computers across short distances, such as within a building. A LAN is privately owned and with less traffic than a MAN or WAN. It has less network traffic congestion. As a result, LANs are relatively high speed. MAN is a metropolitan-sized network. Many cities use a MAN to provide internet access to their residents. These can be publicly or privately owned. They have relatively more traffic than a LAN, but not as much as a WAN. This results in an average transmission speed. The largest size network is a WAN, or Wide Area Network. These are the networks that allow us to communicate around the world. The Internet is an example of a WAN. With so many computers connected, network traffic congestion is relatively high, and a WAN is not as fast as the smaller-sized networks.
Let's learn about the OSI model. The Open Systems Interconnection, or OSI model, is a conceptual framework that describes the functions of a networking system and provides a visual representation of how networks communicate with each other by sending and receiving data. The OSI model divides network communication into 7 layers, with each layer performing a specific task in the process of sending and receiving data. These layers illustrate the inner workings of a networking system. Understanding the OSI model is beneficial in troubleshooting network problems, as it allows you to isolate the source of an error and narrow the issues down to a specific layer of the model. This short video will discuss Dynamic Host Configuration Protocol, or DHCP. What is DHCP? It is a standard network protocol that allows a server to automatically assign IP addresses to computers and devices on a network. Computers are required to have an IP address to communicate over a network. A DHCP also generates a central database to keep track of devices that have already been connected to a network. This ensures that computers and other devices are not accidentally given the same IP address.
In this video, we will learn about what an optical fiber is, when it is used, and how it works. Fiber optics, or optical fiber, is a cable technology that transmits data in the form of light pulses along a plastic strand or fiber. This technology is used to transmit data at an extremely high speed over a long distance. Optical fiber technology is used in several fields, such as the Internet, telephonic communication, cable TV, and medical science. Some of the components that use this technology include Ethernet switches, routers, firewalls, network interface cards, and fiber media converters. Optical fibers use optical transmission, the process of converting electrical signals to optical signals and vice versa, to transmit data. Before transmission, the data is converted from electrical signals to light pulses. Once the data reaches the intended endpoint, a receiver, the light pulses are converted back to electrical signals. The device that converts electrical signals to light pulses with a specific wavelength and vice versa is called an optical transceiver. Next, in this module, we will explore the various types of optical transceivers. In this video, you will learn about how to correctly handle fiber and copper cables. Careful handling of fiber and copper cables is critical to data center operations. There are 5 types of damage that can be done to fiber and copper cables by physical damage, physical tension, corrosion, electromagnetic loss, and incorrect storage. Physical damage includes tightly wrapped cables and can be prevented by loosely wrapping cables individually. Physical tension occurs when a patch connector or cable is too short. In this case, ensure that your cable is the correct length. For metallic copper cables, there is a risk of cables oxidizing, known as corrosion, so cut a small portion of the outer jacket instead of individual cables. Many data centers might have two kinds of cables, which can create electromagnetic loss. When this happens, install copper cables in a separate conduit away from other cables. And lastly, cables often become tangled when stored incorrectly, so it's a best practice to store cables in an organized manner using Velcro. Zip ties can be used to manage copper cables only. Do not use zip ties to handle fiber cable.
In this video, let's learn about data encapsulation. Data encapsulation is a 5-step process that starts in the application layer of the Transmission Control Protocol/Internet Protocol, or TCP/IP model. Application layer takes the data from data streams, encapsulates them by adding the protocol details, and forwards them to the transport layer. The transport layer takes the data from the application layer and breaks the data into segments, then encapsulates each segment by adding a header with sequence information. Next, data segments from the transport layer come to the network layer, where they are encapsulated with an additional header containing routing information, such as source information and the IP address needed to deliver the data. This encapsulated data is now called a data packet. The data link layer takes data packets and encapsulates them with a header and trailer. The header contains the procedure to deliver the data to the respective receiving device, and the trailer contains error detection mechanisms. The encapsulated data at this stage is called a data frame. Finally, the physical layer takes the data frames from the data link layer and converts them into the right format needed to be transmitted over a network. For example, converting data into radio signals. This is how data is transmitted safely from sender to receiver through networks.
In this video, you will learn about the function of a Network Address Translation, or NAT. A NAT allows devices connected in a private network to use the same public Internet protocol, that is, an IP address. Private networks can be as small as a home or as large as an entire office building. Access to a single public IP address can be shared using a router, gateway server, or proxy server. Internet Protocol version 4, or IPv4, is limited to 4,294,967,296 unique addresses, 3.3 billion of which are available in the public domain. In 2019, some households required more than 20 IP addresses due to the various devices connected to the Internet. Examples could be smart TVs, Amazon Echo, computers, smartphones, and the like. This makes it impossible for a unique public IPv4 address to be assigned to every device connected to the Internet.